Theorem 6.4 is, if in two triangles, sides of one triangle are proportional to the sides of the other triangle, then their corresponding angles are equal and hence the two triangles are similar. That means here the three sides, corresponding sides of two triangles are given to be proportional, and you have to prove that the corresponding angles will be equal, and when that is also satisfied, we can say that the two triangles are similar. And since in the question or in the theorem it is given to be, that is the three sides are proportional is given, the theorem is also known as SSS Similarity Criterion. That is side similarity criterion. Okay. So in order to start the proof, first we are considering two triangles ABC and DEF such that their corresponding ratios are equal. Okay, consider triangle ABC and triangle DEF such that AB by DE corresponding sides are proportional, equal to BC by EF equal to CA by FD. Now for each of the fractions, this is given in the theorem. Okay, for each of the fractions, why we are saying, now we are saying that this is less than 1. Now what is the concept of less than 1? Because this triangle is smaller than this triangle, the sides, that is AB and DE, the side AB will be smaller than DE, so that the fraction will be less than 1. That's why we are writing this less than 1. Each of the fraction will be less than 1. Okay, now again we are using the same process, that is the construction, as we used in AAA similarity. What was that? We are cutting DP equal to AB. That means the measurement of AB is taken from the point D on DE, so that it has been cut like this, so that DP is equal to AB. And again for AC, the length is taken from the point D on DF, so that we will get a point Q and we will join these two. Okay, so what we are getting is, we are just cutting DP is equal to AB and DQ is equal to AC, and we are joining P and Q. Okay, this much is our construction. Now we are just considering the first and last fraction. Okay, that is AB by DE is equal to AC by DF. Only last two fractions we have considered, and we are just replacing the value of AB with DP and AC with DQ. That means from here you will get DP by DE is equal to, what is AC? Instead of AC we will write DQ by DF. Now you go for the figure, DP by DE is equal to DQ by DF. That means by the converse of BPT you can say that PQ is parallel to EF. Now why we are doing like these things is, we will show these two are parallel. That means we will get the corresponding angles to be equal. Hence we can show that this smaller triangle DPQ and the bigger triangle DEF are similar by AA similarity criterion. Okay. So what we have got, DP by DE is equal to DQ by DF, and from that we can say that PQ will be parallel to EF. How? By converse of BPT you are getting this. Now since these two lines are parallel, their corresponding angles will be equal, right? So this angle will be equal to this and this one will be equal to this one. That is, you are getting angle P is equal to angle E and angle Q is equal to angle F, and for both the things you have the reason corresponding angles. Okay. Now since these two pairs are giving you to be equal, you can say that the triangle DPQ and DEF are similar. Okay, therefore triangle DPQ is similar to triangle DEF. And what is the reason behind it? By AA. If two angles are equal, then the third will also be equal. So we are just using two angles concept, that is by AA similarity criterion you are getting the two triangles to be similar. Okay. So since these two are similar, their corresponding sides will be equal. What are the corresponding sides? DP by DE is equal to PQ by EF equal to DQ by DF. This is what we are getting. DP by DE is equal to PQ by EF is equal to DQ by DF. Okay. Now from this we are taking only two fractions, that is these two fractions. Okay. DP by DE is equal to PQ by EF. Now our ultimate aim is to get BC is equal to PQ, so that these two sides correspondingly are equal, and this also will get, and then we can use by SSS congruency, the two triangles are congruent, then we can make the corresponding angles also equal. That is our main purpose. Okay. So from these two conditions, what we are doing is we are just replacing, since we have DP is equal to AB here, we are just replacing DP with AB, so that we will get AB by DE. Instead of DP I have written AB by DE is equal to PQ by EF. Okay. Now again go for the condition which is given in the question, which is AB by DE is equal to BC by EF. So here instead of AB by DE I am using BC by EF. BC by EF is equal to PQ by EF. This is by construction, and this is by given fact. Okay. Clear? Or you can say, since AB by DE is equal to BC by EF, we have replaced these two values. Now from this, see, denominators are equal, so you can say that BC is equal to PQ. So if we consider the triangles ABC and DPQ, ABC and triangle DPQ, the three conditions which we are getting are DP equal to AB, DQ equal to AC and BC equal to PQ. That means all the three corresponding sides are equal, right? Considering these two triangles, we are getting AB is equal to DP, AC is equal to DQ and BC is equal to PQ. Therefore, by SSS congruency, triangle ABC is congruent to triangle DPQ. Okay, we got the congruency of these two triangles. That means we can say that the corresponding angles will be equal. That is, angle A will be equal to angle D, angle B will be equal to angle P, and angle C equal to angle Q. Okay, angle A equal to angle D, angle B equal to angle P, angle C equal to angle Q, and the reason for this is by CP CT. Okay. So angle A equal to angle D, we are not changing it, but just see angle B equal to angle P, and here you have got angle P is equal to angle E. So that we will get angle B is equal to angle E, and angle C is equal to angle Q. Here angle Q is equal to angle F, so that comparing you will get angle C is equal to angle F. Okay, and this is, suppose this is your equation number 1, by 1 you can write. Okay, therefore what you got, all the three pairs to be correspondingly equal. That means all the angles, their corresponding angles are equal, and hence the two triangles will be similar. Which are the two triangles? Therefore, triangle ABC similar to triangle DEF. Okay. Next theorem or next criterion is SAS Similarity Criterion. Now what is SAS? Side angle side criterion. That means you have two sides to be proportional given and one included angle. They are equal. Okay, then you can say that the two triangles are similar. Now just go for the statement of the theorem 6.5. If one angle of a triangle is equal to one angle of the other triangle and the sides including these angles, which are the sides here, AB and AC here, and DE and DF here, these angles are proportional, then the two triangles are similar. So what are given? Angle A is equal to angle D is given. If you are taking triangle ABC and triangle DEF, you have angle A equal to angle D given, and AB by DE equal to AE by DF is given. And you have to show that the two triangles are similar. Okay. Now in order to start the proof, we are considering two triangles. Consider triangle ABC and triangle DEF such that what all we are taking? Angle A is equal to angle D and AB divided by DE is equal to AC by DF. And this fraction will also be less than 1 because we have taken AB to be a smaller triangle than DEF. Okay, these are the two concepts given in the question itself. Okay, now what we are doing is we are just again cutting DP and DQ in such a manner that DP will be equal to AB and DQ will be equal to AC. Okay, cut DP equal to AB and DQ equal to AC, and then join PQ. This much we are doing for all the theorems. This concept is there. Okay. Now our purpose is to show that these two triangles are congruent. Okay. For that, what all we have, we just see AB is equal to DP we have, AC is equal to DQ we have, and included angles are equal. So by using the congruency, which congruency? SAS, you can say that the two triangles ABC and DPQ are congruent. Okay, so we have to consider the triangle ABC and triangle DPQ. Here you have AB is equal to DP, angle A is equal to angle D, AC is equal to DQ. These two are by construction and this is given in the question itself. Okay, by question, given condition, and these two by construction. So by these three you are getting, by SAS congruency, triangle ABC is congruent to triangle DPQ. Now since you have this congruency, the remaining parts will be equal, so that you will get angle B is equal to angle P and angle C equal to angle Q. Okay, therefore angle B is equal to angle P and angle C is equal to angle Q, and the reason is by CP CT. Okay, now we are considering this fraction AB by DE equal to AC by DF, and we are just replacing the value of AB with DP and AC with DQ, so that we will get DP by DE is equal to DQ by DF. Now in the figure, in this triangle, you just see DP by DE is equal to DQ by DF means that by the converse of PPT for this triangle, if you have this fraction to be satisfied, these two lines will be parallel, that is PQ will be parallel to EF. Okay. Therefore, PQ parallel to EF by the converse of BPT. Okay, now since these two are parallel, you will get the corresponding angles to be equal. That is, angle P equal to angle E and angle Q equal to angle F. What is the concept? Corresponding angles. Since they are corresponding angles, they are equal. Okay. Now just see, you have your concept angle B equal to angle P already got, and here you got angle P equal to angle E. That means angle B equal to angle P, angle P equal to angle E will give you angle B equal to angle E. So if you are marking this as equation number 1 and this as equation number 2, you can write from 1 and 2 you will get angle B is equal to angle E. So this and this became equal. This and this equal, this and this equals, you are getting this and this to be equal. Again here you have angle C to be equal to angle Q. Okay, and angle Q is equal to angle F. That means angle F and angle C are equal. Angle B equal to angle E and angle F. C equal to angle F. Therefore, so from these two triangles, in triangle ABC and DEF, you are getting two pairs to be equal, so that you can use AA similarity. Therefore, by AA similarity, because the third is automatically equal or you have already taken it to be equal, right? So by AA similarity, you will get triangle ABC to be similar to triangle DEF. This is your theorem, proof of the theorem, which is SAS similarity.